All right, we are looking at probability distributions here. So let's start with a random variable. A random variable is a variable whose value is determined by the outcome of an experiment. Okay, so a variable whose value, probably should have given you a little more room here, sorry about that, is determined by the outcome of an experiment. There are two types of random variables. You have a discrete random variable and a continuous random variable. All right, so same as with your types of data, discrete and continuous. Discrete will be countable. So there will be gaps in between the values. An example of that would be the number of. So you're still going to have that key there, number of. So number of heads obtained in a coin toss. Number of siblings is another example. And then continuous will assume any value contained over an interval. So those are going to be measurable values. So you're going to have length, time, price, or weight. Okay, then we're going to look at a probability distribution. So we're going to start with discrete random variables here. So the probability distribution lists all of the possible values of a random variable and their corresponding probabilities. The probability distribution will list all possible values of a random variable and their corresponding probabilities. So two rules for a probability distribution. The first rule is that the probability of the variable must lie between 0 and 1. Okay, and that can also be written like this. You have 0 is less than or equal to the probability of x, which is less than or equal to 1. So the probability of x is between 0 and 1. The sum of the probabilities in a probability distribution must equal 1. So when we add, find the sum of p of x, those will all be 1. So here's an example. So according to a survey, 60% of all students at a large university suffer from math anxiety. So what you're going to be given the probabilities already in chapter 5. So you will not have to find them. They'll be given to you. You just convert them to a decimal. 2 students are randomly selected from this university. Let X denote the number of students in the sample who suffer from math anxiety. Construct a probability distribution of X. So what we're going to do here is we're going to create a tree diagram and then we'll fill this out. So we're going to start with, we're going to let S be those who do suffer. So S will be suffers from math anxiety. Okay, and that is 60%. The only other option is to not suffer, so let's make that N, not suffer. And if the probability that someone suffers is 60%, then the probability that someone does not suffer would be 40%. Those are your only 2 options. They have to add to 1. So 0.6 plus 0.4 would give us 1. So we can create a tree diagram. You have, because you're doing 2 basic pulls of a hat. So on your first pull, you can either get someone who suffers or does not suffer. And then from there, you can get suffer or not suffer again. On either side, if it will let me. There we go. Okay, then we can record the results. We would have suffer, 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 then not suffer, then not suffer, suffer, not suffer, not suffer. So we have the possible sample space here. Now we want to find the probabilities. So we have the probabilities. Okay, this is joint probability, so we're just going to multiply them. So suffer, suffer would just be 0.60 times 0.60. So that would give us 0.36. Okay, then we can fill this in. So first one, suffer, suffer, the probability would be 0.36. Then you have suffer, which would be a probability of 0.60, and not suffer, which would be a probability of 0.40. And that should give you a 0.24. So suffer, not suffer, 0.24. Then you have the same thing here, except the order is reversed, so it would be 0.40 for not suffer times 0.60 for suffer. So again, you'd have a 0.24. And then you have not suffer, which would be 0.40 times 0.40. Which would give us a 0.16. And then to check that we did the probability distribution correctly, you want to find the sum of P of X. So we would add all of these together. You have 0.36 plus 0.24 plus 0.24 plus 0.16. That adds to 1. Those are all the possible probabilities. These are all the possible outcomes that we can get for our probability distribution. Okay, the next example, we're just determining whether something is discrete or continuous. So let's take a look here. So discrete says number of, continuous is measurable. So the number of new accounts opened at a bank during a certain month is going to be discrete. Okay, number of. Time taken to run a marathon, time is continuous. Price of a concert ticket, price is going to be continuous. Number of rotten eggs in a randomly selected box, discrete. Points in a football game, that is going to be, yes, discrete. Okay, so points are a number of, there's, 2 points, well, 7 points, 6 points, 7 points, 3 points, increments, if you're looking at a football game. Weight of a randomly selected package, continuous, good. Okay, let's look at another probability distribution. So we have here, according to a survey, 35% of employees working at a very large company are happy with their jobs. Suppose that 2 employees are selected at random from this company. Let XX denote the number of employees of the sample of 2 who are happy with their jobs. Construct the probability distribution. Who are happy. Draw a tree diagram. Okay, so we have 35% are happy. So you have 2 options, happy or not happy. So we're going to go H for happy, which is 35%, so 0.35. And N for not happy, what percent is that? 65%. Okay, so not a very happy company, really, overall, if you look at it. So you have 35% for not happy, 65% for happy, and we want to do a tree diagram. So it's two people that you're selecting, 2 people at random. So it's very similar to the tree diagram we just did. So you're going to start, you're going to have your first pull, happy or not happy. And then your second one, again, happy or not happy. So you have happy, happy, that's one possibility, which would be 0.35 times 0.35. So let's see what that gives us. That is going to be 0.1225. Then you have happy, not happy, which is going to be 0.35 times 0.65. That's going to give us 0.2275. Then not happy, happy. So that would be a 0.65, 0.35. Again, that should be a 0.2275. And then not happy, not happy would be a 0.65 times 0.65. So 0.4225. Okay, let's add all these together just to check. So you have 0.1225 plus 0.2275, 0.2275, and 0.4225. All right, we get 1 for our probability distribution. There is not a question, I think I might have cut that off, but it says let XX denote the number of employees of the sample of 2 who are happy. So the question I think I cut off is what's the probability that 2 people are happy? So the probability of happy, happy is this first one here, 0.1225. So that would be the question there. So if this was an actual survey in an actual company, they would say, well, the probability that 2 people are happy is only 12%. That might be something we want to do to boost morale around here. Okay, so that's how companies make decisions. All right, let's move on Let's look at formulas. So we're going to do mean and standard deviation. Now these ones, unfortunately, you do standard deviation and mean when we have raw data, but when the probability is already given to us, the calculator won't compute that for us. So we have formulas to use, but the formulas are not bad. So this is the formula for mean. So you have mu for mean. Okay, mean is the same thing as expected value here. That's what that E of X is. So E of X is expected value in a probability distribution. And the formula is just the sum of X times P of X. And then the standard deviation, that's your sigma, your lowercase sigma there. Okay, that formula is going to be the square root of the sum of X squared times P of X minus the mean squared. And then because standard deviation is the square root of the variance, if I wanted to find the variance, I would just take the standard deviation and square it. So let's do an example using these formulas. So I have here the following table lists the number of breakdowns per week and their probabilities for a machine based on past data. We want to calculate the mean and the standard deviation here. So breakdowns, 0 through 4, probability. Breakdowns, that's going to be your X. Okay, your X is your number of breakdowns. So number of, that's your X. Probabilities are already given to us. Okay, we want to fill out this table so that we can find the mean and the standard deviation. So X times P of X is just this column times this column. So 0 times 0.2 is 0. 1 times 0.2 is 0.2. 2 times 0.3 is 0.6. 3 times 0.30, hold on a second, I've got something whited out on here. I think there might be a typo. Find the sum of P of X. Let's make sure that's right. I think it's, yeah, it's over. This here is a typo. Make that 0.2. There you go. Always check this here. So sum of P of X should be 1. Now that'll be 1. Okay, then 3 times 0.2 is 0.60, and 4 times 0.1 is 0.40. Let's add this column together. That'll give us the sum of X, P of X. So this is the sum of X, P of X, which is also the mean. So let's see, that's 0 plus 0.2, 0.6, 0.6, 0.4. So 1.8. All right, so that's our mean. The sum of X, P of X, 1.8. What does that mean? That means that's the average number of expected breakdowns in a week. Okay, following lists the number of breakdowns per week. So the average number of breakdowns in a week. So over a year, 6 months, however many weeks we're studying, about 1.8 on average. Then we want to find the standard deviation. We are going to need X squared. We're going to need X squared times P of X. So X squared is just this column squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And then it's x squared times p of x. So it's this column here times the p of x. So 0 times 0.2 is 0. 1 times 0.2 is still 0.20. 4 times, and you're going all the way over to p of x, so be careful there, don't do it by this column. So 4 times 0.3 should be a 1.2. Then you have 9 times 0.2, that's going to be a 1.8. And then 16 times 0.1 should be 1.6. Yeah, 1.6. Okay, then if I sum this column, that's going to give me the sum of x squared p of x, which I will need. So let's see, 0 plus 0.2, 1.2, 1.8, 1.6. So 4.8. All right, so our standard deviation formula is going to be the square root of the sum of x squared times p of x minus the mean squared. So if we plug those values in, the sum of x squared p of x is this 4.8 here. The mean is 1.8, and we want to square that. Okay, so we can put that in the calculator exactly like that, or we can do it step by step. We can do 1.8 squared. So that's 3.24. So I have square root of 4.8 minus 3.24. So let's go ahead and do that. Square root of 4.8 minus 3.24. So there I'm going to get a 1.249. We'll do 3 decimal places there. So 1.249. Okay, and if you're doing it step by step, just don't forget to take the square root. So if I did 4.8 minus 3.24, don't forget to then take the square root of that number. So the standard deviation is 1.249. So you could add to this sentence, the average number of breakdowns in a week is 1.8 with a standard deviation of 1.249. Okay, so like we said in the very beginning, give or take 1.249 on any given week. So some weeks you might not have any breakdowns because that would be below 1. And some weeks you might have 3 to 4 if you add and subtract this. Okay, and then we can actually do this. So I changed this. So defective parts, we just need breakdowns. So you can cross all this out and just write breakdowns. All right, so the probability that at least 4 breakdowns. So we want to look up at our probability distribution table here. So you have the probability of at least 4 means there are greater than or equal to 4 breakdowns. Now here you're just pulling the data from the table. So 4 or more would be here. 4 or more. There's no more than 4, so it's just this 0.10 here. Okay, probability of at most 3 breakdowns. So at most means 3 would be the greatest number of breakdowns, which means it's less than or equal to 3. So then in that case, that is 3, 2, 1, or 0 breakdowns, which means you would add all of these probabilities, or you could just subtract the 0.1 because that's the only other probability there is. Okay, let's say we're going to add them all. You've got 0.2 plus 0.2 plus 0.3 plus 0.2. And that's going to give you 0.9. Okay, probability of less than 5 breakdowns. Well, all of these values are less than 5, so that's going to be 1. There's always going to be less than 5 breakdowns there. And then the probability of at least 1 breakdown would be the probability that it is greater than or equal to 1. So it's going to be all these probabilities except the probability of 0 breakdown. So it's the probability of 1, 2, 3, or 4 breakdowns. So we would add those, 0.2, 0.3, 0.2, and 0.1. And that should give you a 0.8. Okay, so take a look at this problem real quick. Try and figure this out. I'll give you just a few minutes here. And that both of these, take a look at both of these before we move forward. I'll give you just about 5 minutes. So if we read through this first problem, we have a waiter estimates that he makes a tip of $5 on 20% of his tables, $8 on 50%, and $14 on 25%. The first question says what percentage leaves no tip. So you are going to have a percentage here with no tip. So if we take that into consideration, you'll have X be the tip. So you've got a 0, $5, $8, and $14. Okay, and then we have the percentages. So that's your probability. So kind of set up a little distribution table here. All right, so you have $5 is 20%, so that's going to be a 0.20. $8 is 50%, so 0.50, and 14 is 25%. So the percent that leaves no tip, let's add all these together. And let's see, that's going to be 0.95. So the rest, 1 minus 0.95, 0.05. So the probability is 0.05. The question wants it as a percentage. So this one you would answer as a percentage. You would say that 5% leave no tip. Okay, the probability is 0.05, but if it asks as a percentage, you would then convert it to percent. What is the expected value of a random tip? That is the mean. So that is just the sum of X times P of X. That's going to be your expected value. So X times P of X, we can just go ahead and do this in our calculator since it's short. So you have 0 times 0.05, that's 0. 5 times 0.2, 8 times 0.5, and 14 times 0.25. So add all those together, 0 plus 1 plus 4 plus 3.5. So 8.5. So the mean is 8.5, which means the expected value of a random tip is $8.50. So on average, his tip, $8.50. All right, second problem, you have let x be the number of errors that appear in a randomly selected page of a book. The following table lists the probability distribution. Find the mean and standard deviation. Okay, so you're finding the mean and the standard deviation. So for the mean, you want x times p of x. So we can go ahead and set that up here. So x times p of x. So first you'd have 0 times 0.73 would be 0. 1 times 0.16, 0.16. 2 times 0.06 should give us a 0.12. 3 times 0.04, 0.12. And 4 times 0.01, 0.04. Add all of these together, that's going to give us our mean. So let's see. So 0.44. Okay, so the mean is going to be 0.44. And now the standard deviation, we are going to need x squared times p of x for that calculation. So remember, that's going to be the square root of the sum of x squared p of x minus the mean squared. So we have the mean. We need x squared times p of x. So let's get x squared. So 0 squared is 0, 1 squared 1, 2 squared 4, 3 squared 9, and 4 squared 16. X squared times p of x. So 0 times the original probability, that's still 0. 1 times 0.16, 0.16. Then you have 4 times 0.06 is 0.24. 9 times 0.04, it should be, I think, 0.36. And then 16 times 0.01 is going to be 0.16. So then this sum, let's see what that is. So that's going to be a 0.92. So the sum of x squared p of x is 0.92. So if we plug this into our formula, you're going to have, let's see, the square root of 0.92 minus 0.44 squared. Okay, you can put it in the calculator just like that, I believe. Let's try it. So 0.92 minus, we'll do 0.44 squared and then close that. We get yep, that should be right, 0.852. Or if you like to do it one by one, I would just go 0.44 squared. Okay, then 0.92 minus 0.1936, and then take the square root of that number. You should still get the same thing. All right, so let's move along. Let's talk about binomial experiment. All right, so we have binomial distribution is one specific type of discrete probability. A binomial distribution is the probability distribution that results from a binomial experiment. So this is also called a Bernoulli trial. It's a Bernoulli after a famous statistician. Who came up with this? So there are 4 characteristics. So this will come up on your test on vocab for sure. So the first one is that the trials are identical. Okay, which means they're performed under the same conditions. You want to write that, you can. Okay, so I flip a coin, same way every time. you have two outcomes. So two outcomes and only two outcomes. Okay, those two outcomes are either success or failure. Depending on what you consider. Or you could have yes, no. So from our first example, you suffer from math anxiety or you don't. You're happy at work or you're not. There's no in between, yes or no. The probability of success is constant, is the third one. And all that means there is that the sum of the probabilities adds up to 1. So we say here mathematically P plus Q equals 1. And then just to go along with this, P would be the success and Q fail. And then step 4, the trials are independent. Okay, so you are going to be told if it is a binomial distribution, but you do want to just check, okay, but you definitely need to know these for vocab. First, verify that the discrete data satisfy the conditions, and then you use, if they don't satisfy, use the formulas we just did. Okay, and then if they do, then you're going to use these formulas. So these ones are super easy. You have the mean, or the expected value, is just n times p. So n being sample size, or the number of trials, p, probability of success. And then the standard deviation is going to be the square root of n times p times q. All right, so how to compute using these formulas. To find the probability for each variable in a binomial distribution, here is your formula. So P of x, okay, we're going to use the combination formula. So it's going to be n cx for your combination, and then it's P to the x and then q to the n minus x. Okay, where n is the number of trials, p is the probability of success, q, probability of failure, x, number of successes in the trials, and minus x, number of failures in the trial. The C, that's the combination formula. So we went over that in 4.6. So the combination formula, if you wanted to do it by hand, we're not going to do it by hand, but we'll use the calculator. But here it is by hand. It's n factorial over n minus, it would be n minus x in this case, factorial, and then x factorial. If you wanted to do it by hand, we're going to use the command in our calculator on math. All right, so let's look at an example. So we have 70% of students at a college with a large student population use a social media site Instagram. 3 students are randomly selected. Okay, so for this problem, n is 3. Okay, we're going to do P, be the people that do have Instagram, because it says 70% do have Instagram. So P is going to be the 0.70. So P is yes, Instagram. And then we're going to do Q is that they do not have an Instagram. I don't actually call it Insta, I just don't feel like writing the whole thing. So Q would be what? 0.3, yeah, 70% have it, 30% don't. Okay, so we're going to construct a binomial probability distribution. So in the probability distribution, you have 4 possibilities. You could have that, and you're just picking one student or 3 students randomly. So you could have first that 0 of the students have it. You could have 1 out of the 3 have it. You could have 2 out of the 3 have it, or all 3 students have it. Then for each probability, you're going to do the formula. Okay, so we'll start with 0. So the probability that 0 students have Instagram. All right, so we want to do N, C, X. So N is going to be 3 every time in this. So the N is 3, C, 0. That's the first part. Okay, and then it's P to the X. So your P is 0.7. So 0.7 to the 0. And then your Q, 0.3. Okay, to N minus X would be 3 minus 0. So a lot of calculator work here. So we're going to do 3C0. So again, that's math. So you would go 3, then math, over to PRB, third one down. So 3C0 is 1. So this first part here is 1. 0.7 to the 0 power is 1. Anything to the 0 power is 1. And then you have 0.3 to the 3 minus 0 is just 0.3 to the third. So that's going to be 0.027. So 1 times 0.027 is 0.027. So the probability that 0 students out of the selected 3 have Instagram is 0.027. Okay, and then we're going to do this with 1. I'll change the color. Okay, so the next one is 1. You've got 3 is still that N, so 3, C, 1. Then 0.70 to the first power. Then 0.30 to the 3 minus 1. All right, so 3C1, 3, math, over to probability, and CR1, it's going to be 3. So the first part here is 3. 0.7 to the first, 0.7. And then this is going to be 0.3 to the 3 minus 1, so that's 0.3 to the second power. So 0.09. Okay, then you multiply 3 times 0.7 times 0.09. That's going to be 0.189. So the probability that exactly 1 student has an Instagram and 2 do not, 0.189. All right, now we'll do it with 2. Let's go pink here. Okay, so probability of 2. You have 3C2, 0.70 to the second power, then 0.30 to the 3 minus 2. So let's do each of those. So 3, math, probability, NCR 2. That's going to give us 3. Then 0.70 squared. So 0.49. And 0.30 to the first, just 0.30. So let's see, 3 times 0.49 times 0.30. that's going to be 0.441. So the probability that exactly 2 students have Instagram and 1 does not, 0.441. And then we'll do this with 3. Okay, so this is going to be 3C3, 0.70 to the third, and then 0.30 to the 3 minus 3. All right, so C3, 3C3, there we go, should be, I think, 1. Yeah, 1. Then 0.70 to the third is going to be 0.343. And 0.30 to the 0, that's just 1. So this is 0.343. So then the probability that all 3 students have Instagram, 0.343. You want to check to make sure you did it right, add the probabilities. So 0.027 plus 0.189 plus 0.441 plus 0.343, we get 1. Okay, so the sum of the probability distribution is 1, which means we did this correctly. Yes. That's just up here. So the x is changing. Notice that everything was the same each time except the x. So the 0, 0, 0, then it was 1, 1, 1, 2, 2, 2. So that part, yeah, you do that right in the beginning and then it changes every time. All right, and then if we wanted to find the mean and the standard deviation for this, the mean is going to be n times p. So that's 3 was our n and p was 0.7. So I think that is 2.1. Yeah, 2.1. So at this college, on average, 2.1 students use Instagram with a standard deviation of, this is going to be n times p times q under the square root. So 3 times 0.7 times 0.3. So you can go ahead and just put that right there in square root. So 3 times 0.7 times 0.3. And just close that. So 0.794. With a standard deviation of 0.794. Questions based on the distribution. What is the probability that exactly 2 of these 3 students use Instagram? Okay, that's right here. P of 2, 0.441. What is the probability that at least 1 of these students use Instagram? So the probability that they're greater than or equal to 1. So that would be just these 3 here. So 0.189 plus 0.441 plus 0.343. So 0.973. All right, what time is it? Okay, we do have time for me to show you to do this on your calculator because this is time consuming. It's not bad when you only have an n of 3, but I think if we look at our next example, we've got 10. Okay, so this one we're going to do in our calculator so I can show you guys. At the Express House Delivery Service, providing high quality service to customers is the top priority of management. It is known from the past that despite all efforts, 5% of packages mailed through this company do not arrive at their destinations with a specific time. Suppose corporation mails 10 packages through express house delivery on a certain day. Construct a probability distribution for this data. Okay, so what we're going to do here is let's find our variables. So n, okay, we're mailing 10 packages. So we have 10 trials. Okay, they're all identical. The probability is that they arrive on time or they do not. Okay, so P, it's given to us in terms of the ones that do not. So that's going to be the success because we're doing it in terms of what they gave us. So that's your P is always what they give you. So P is not on time, which has a probability of 0.05. Q is then going to be on time. What's the probability for on time? Yeah, 0.95. So 5% are not, but 95% are on time. And then we are just doing the distribution table. Okay, so in our distribution table, you're going to fill in your x's. So you're going to have 0, 1, 2, 3, through 10. All right, so I'm just trying to remember how to do this. Okay, so in a calculator, we are going to go, see this button here? It says vars, just to the left of clear. Above it says distribution. All right, so we're going to try this together. So you're going to go second, distribution. Then I think we want binomial PDF. So if you scroll down, for me it's 0, binomial PDF, not CDF. Okay, binomial PDF. That's what you want. Now, if you have the 83, it's going to go like this. If you have the 84, it's going to come up with certain things. So in here, you want NPX. Okay, so here I would do 10, comma, my probability is 0.05, my P, and then my X. I'm going to do the first one, 0. Okay, that's going to give me a 0.599. Okay, so let me just write this down for you guys. So in our calculator, you have second, and you want DISTR. It's above vars. Then for me, it's 0. I think it is for the 84 as well. And then it is NPX. So I am doing this command, binomial PDF, and then 10.05, and then the X changes. Okay, I can do that each time, or I can put it in a list. Yeah, okay, so I'll do the list too, but for the 84 plus, I believe you get a table that looks like this, binomial PDF, I think it's your A actually, instead of 0 for me, for the 84. I think it is A, the command. It'll say trials. So you're going to fill in the number of trials, and then the P, and then the X. And then you put the X in. And then you would hit calculate on your 84. All right, you can do this in a list or you can do each one individually. Lists are going to make it less time consuming for you. So I'm going to put this in a list. So stat, edit, I'm going to do L1, 0 through 10. Okay, then I'm going to scroll over to L2. I'm going to highlight L2, and then I'm going to do the command. So I'm going to go second, distribution, I'm going to go to binomial PDF, and then here I'm going to put my N is 10, comma, my P is 0.05. My X, however, I'm going to grab from L1. So I'm going to do second 1 for L1 for my X list. Close the parentheses and hit enter. And it's filling in the table for me. Okay, so you see the table is filled in for us. Now the probability is so small that by the time we get to just 4, you're 0.0009. Okay, so let me help you fill this out. You've got, for 1, it is 0.315. For 2, 0.075. For 3, 0.010. For 4, it is, in scientific notation, 0.0009. Then for 5, 0.00006. Then for 6, you've got 5 zeros and a 3. And then the rest are so small that I would just put 0. So 0, 0, 0, 0. Okay, and I am recording this, so if you need help with this again, you can do this. You can always do it one by one. I'm not going to give you one on the test that's more than probably 4, so you can do them all by hand. Not too bad. You might on the homework have up to 10, but I don't think you're going to have more than that. But let's answer some questions. Once you have the probability distribution filled out, find the probability that exactly one of these 10 packages will not arrive within the specific time. So that means it's just P of 1. So P of 1, if we look up at our table, is 0.315. Find the probability that 3, 6, or 9 of these 10 packages will not arrive. So it's OR probability, so we're adding. So it's just probability of 3 plus the probability of 6 plus the probability of 9. Okay, so the probability of 3 is, let's see, that was 0.010. 6 was 0.000003, and 9 was 0. So if we add those together, if I go back to my home screen, you get 0.010003. And then find the probability that at most, one of these 10 packages will not arrive at its destination. So the probability is at most 1, which means less than or equal to 1. So that there for you is going to be the 0 and the 1. So 0.599 plus 0.315. So 0.914. All right, and then just some quick characteristics of a binomial distribution for the shape. So the probability is less than 0.5, is equal to 0.5, or greater than 0.5. So if the probability is equal to 0.5, or P, so the probability of success, then you're going to have a symmetric distribution. If it is greater than 0.5, you are skewed left. Less than 0.5, you are skewed right. So what that looks like here roughly is this. This is a probability that is less than 0.5. So we are skewed right, which means you have more probability on this side. and then it just kind of flattens out as you go to the right, something like that. P is here, it is 0.8, so it's just going to be the opposite, something like this. And then here you have a P of 0.5, which means it is symmetric, so normal distribution here for you. And that's just some vocab for you. And that is everything for chapter 5. So I'm going to leave the practice problems for the virtual session. And you guys can go ahead and start on your homework and quizzes after all of this. So I know it's a lot, but just take it one by one. It shouldn't be too bad.